Hello everyone. So in this video, we're going to see the question, check if a linked list is palindrome. Okay. So given the head of a singly linked list, we have to return true if it is a palindrome and return false if it is not a palindrome, right? So let's just see the question. And for this, let's start with, do you know what a palindrome is? I would like to start. I'm really sorry. So I would like to start with, do you know what a palindrome is? So palindrome is, if you read it from first alphabet or if you read it from the first character, whatever it be, and you read it from the last character, whatever you're going to get the same answer. Now, let's say we have a name as Naman, right? If I read it from here, it is Naman. And if I read it from here, it is still going to be Naman. Okay, so if you read it from the first, if you read it from the last, it is going to be the same. Given the example, this is the palindrome because if I read it from this ways, it's going to be 1, 2, 2, 1. While if I'm going to read it from this ways, it is still going to be 1, 2, 2, 1. And for this, if I read it from this way, it is 1, 2. And if I read it from this ways, it is 2, 1. Hence, it is not a palindrome. Makes sense? So I hope now you know what is a palindrome, right? So now let's see how to check if a linked list is a palindrome. So, whenever it comes of reversals, and if you've already studied stack before, you know that, you somehow think maybe it is possible to do it with a stack. So that is what my first approach is going to be around this. So let's just say I have 1, 2, 3, 3, 2, 1. That is your even characters. And then we're also going to do it with 1, 2, 3, 2, and 1. Your odd characters. Make sense? Now let's just do it with your approach 1 that goes with a stack. Okay. So the approach 1 that uses, what am I going to use? I'm going to use stack for here. So what I am going to do is I have, let's say, this as my array. Oh, sorry, this as my linked list. I'm really sorry for this. So let's just draw it. 1, 2, 3, 3, 2, 1, and then null. So if I have a stack, what I have to do is I have to traverse it from here, keep putting everything into my stack. So basically you have to iterate and then push everything into your stack. What does your push complexity is? Constant, O of 1. Big O of 1, okay? So you have to move it all across this way and then keep pushing everything into your stack. And then the second step is you have your head pointer here, right? So now you have to again traverse your linked list, this time checking it with your stack's topmost element, because this topmost element is your end of linked list element. Does that make sense? Right? So I will check my 1 with this. It says it's a match. Then I say, okay, move this to the next and pop this off. Again, I check it with the top element of the stack, 2 and 2. It's a match. Again, I pop an element from the stack. I move the linked list pointer to the next of the element. Then again, I see 3 and 3. It's again a match. I again pop off the element from the stack and move the pointer to the next. 3 and 3. It's again a match. I again pop an element from the stack, move the pointer to the next element of my linked list. 2 and 2, it's a match. I again move it. I again pop an element out of the stack and also move my next pointer. Next pointer, it's again a match, and this was the final element. The top says 1. Sorry, I'm really sorry. Yeah. The top says 1 and the pointers and the pointer reads 1. It's again a match. You pop off the element, you move your next, the next moves to null, and you're done. The entire thing was a match. And let's assume Had we be having a not match thing, let's say we were having, just that I was ending it with 5. So what could have been the first element be here? The topmost element could have been 5 because that would have been then the end of the linked list. And then I would have been checking your 5 with your 1 and it was not a match and I could hence be returning false. Then and there, no need to check it further. But if it's a match, we keep checking it further until we reach the end of the stack or we reach the null of the linked list. So here, let's just talk about your time complexity. Big O of 2n, I would say why? First time the traversal for pushing everything into the stack and next time the traversal to check for the palindrome. Make sense? Space complexity, big O of n, that is for stack. This seems pretty decent because big O of 2n is nothing but big O of n, that is your linear time complexity. So what do we have to reduce up? We have to try to make this space complexity go off. And for this, we have our next approach coming up. Does that make sense with everyone? Right? So in our next approach, what do we have? Let's say the linked list goes by 1, 2, 3, and 2 and 1. So basically, just, try to figure out this. Try to just imagine of this, I would say. This is your first part of the linked list. And this is your, or I would make it rather simple by just doing what? Since this is the first, I will make this. Okay. So this is your first part of the linked list and this is your second part of the linked list. Make sense? What I have to check is, if I tell you, if there is a way, somehow I just go in, take the second part of the linked list, only the second part of the linked list. And what I do with the second part is, I just reverse it. Reverse the second part of the linked list. So it becomes 1, 2, and 3. And then I check this part. And then I check this part of linked list with original first half. That is, I check 1 with 1, 2 with 2, 3 with 3. Does it make sense? So now your question reduces to finding the middle of the linked list, taking the second half of the linked list, reversing that half of the linked list, and then checking it one by one with your first part of the linked list, the original linked list. Does that make sense? I hope it does. And now let's come, this was your even length of the linked list. Right? And now let's just come to your odd part of the linked list. So let's say of odd linked list. 1, 2, 3, 2. This is still a palindrome, right? Because if you read it this ways, you read it this ways, it still says the same, right? So let's just see how do we solve this part. So what again? This is your first part of the linked list. This is your second part of the linked list. Make sense? I'm taking this part in the first half. You can also take it in the second half depending on howsoever you approach the question, right? So in this part, what do? I'd say there is a way I reverse it off. And then I check this with first half. 1, 1, 2, 2. Now you'll say 3 does not match. So what I'm going to do is I'm going to set the conditional as while my second part does not reach null, while this pointer, let's say PTR, this does not reach null. So if this entire length is matching out here, this entire length is matching out here, I'm not concerned with this because there can be at most one element more in my first half. So I'm checking it against all the elements in my second half, because second half entirely has to be in the first half. The first half can have one element more, right? And if you're taking this third to be in your second part, then you can say my first half has to be in my second half, and my second half can have one element more. Make sense? I hope it does so, right? So now let's just come to the coding part for this. Rest, I think you guys are good with everything, right? If you have any concerns, any doubts, please post them in the comment section, or you can let me know of any reclarification needed using the GForms link attached. Let's just go to the code part for this. Okay, so we need a function to reverse the linked list as well, right? We do need the reversal part as well. So let me just write your reverse linked list code, and I hope you all remember that. So how does it goes by? Reverse linked list. You get a head for it. Make sense? You point your temp to head. You point your previous pointer prev to null. You point, no, you don't point anything then, right? And then you draw up your while until your temp. And then you define your node star. I will take it front to what? Temps next. Then your temps next points to what? Prev. Prev points to what? Temp. Temp points to what? Front. Make sense? So it is this relationship. I hope you remember, because this way this becomes very easy to go with. Else you will have a lot of confusions, what to do, where to do. But if you remember this, it's going to be very easy. And what do you return? You return your ref pointer. So you have written a snippet of code that is now reverse linked list, and this part of the code is what we are going to call from within our actual code for the palindrome situation, right? So they want us to return true or false. What should be the code returning? Bool. Bool is palindrome. What has been given to us? We have been given a head pointer. Makes sense, right? Now, this is our base condition if my head is null. Or let's say my head's next is null. That is, if I have one node or if I have zero node, it is always a palindrome. Make sense? If this part is taken care of, now what I have to do? First step. Find the middle of what? Find the middle of your linked list. Let's go ahead, find the middle of the linked list. So while I'm finding middle of the linked list, what is the way? Node star slow is head. Node star fast is also head. I'm going to use tortoise and hare algorithm for this. But one difference you're going to see now next. While your fast next is not equal to null, and your fast next is not equal to null. Make sense? What am I going to do? I'm going to move slow to the next and fast to the next. And when the fast reaches there, where is slow? Slow is on the middle of the linked list. So why did I do fast next and fast next instead of doing fast and fast next? Because if there are, let's say, even number of nodes, I want the first node to be taken so that I can give second node to the next part of the linked list. I hope you get that, right? So I think when I do the dry run, you're going to understand about this. So we have our next part. So now I'm going to reverse the second part. That, let's say it's my step 2. Reverse second half. That goes by note star, let's say new head. What I'm going to do with the new head, I'm going to give the new head to the, I'm going to get new head after I give my slow to, after I give my slows next to what? After I give my slow head next to this part. And what is this part? Nothing but reverse the linked list. So my second half is going to get reverse. And because I'm giving slows next out here, now you see this. I'm giving my slows next out here. That is why I'm keeping slow. If this is, let's say 1, 2, 3, 4, right? I want my slow to be here so that I can give this part to my reverse linked list. I hope you get it, right? So while when we were asked in the reverse linked list, in the middle of the linked list question, the video, we were asked to return the second part, the second node if we have two nodes as middle. So there we used to do fast and fast next. But this time we want the first node, the slow pointer to be pointing at the first node so that you can give a pointer out here. Make sense? So we'll be doing this. I want a pointer out here so that I can connect this part of the node. Because the second half of the linked list, you are distorting your given input, right? So after everything is done, you have to re-reverse or you have to reverse it back so that it gets to its original form and then return it entirely, right? You don't have to return it, but we cannot distort the input that is given to us. That is wrong. So we have to get the input back into the correct format. So if this function, this part of the linked list, we are reversing it for our own use, right? For finding the palindrome. After we are done with all our logics, after, we have found that if it is a palindrome or not a palindrome, we have to re-reverse it or get back to its original format. And how will we attach it then? Because we want a pointer here. Because we do not have a back pointer in singly linked list, right? So we have to keep the pointer right here so that we can attach that linked list back right again. I hope you're getting it, right? And then we get this. We have our second half reversed. Now what we're going to do? Step 3. Check first half with the second half. How do we check that? We're going to take your note star first as your head, note star second as your new head. And while what is not null? While second is not equal to null because my second is one second could be equal to first and second could be one step lesser or one node lesser than the first half. So it makes sense to check second. Okay. If first's data is not equal to second's data, what will happen? What should we do? What do we have to do? We have to re-reverse it and return false. So what will you do? You will reverse your linked list with what? Your new head and then return false. Make sense? But if it is equal, then what? First is first's next and your second is second's next. Now, let's suppose you reach the end of the linked list. Everything is matching. Everything is, checking up against each other in a good state. That is, everything is matched in your second part with your first part. Maybe you could have one node extra in your first half. You could not have. That is different. But we have done a palindromic condition check and that is all satisfied. So what do we do next? We have to reverse the linked list and then return true. So what do? I just reverse my linked list. With what? With my new head And then I return true for this case. So what do we have the complexities as? Your time complexity still remains same. Your time complexity goes by big O of n, while your space complexity becomes big O of 1 because we did not use any extra spaces. I hope this makes sense, but if you still have any questions, any concerns, please post them in the comments box. You can also make use of the G forms attached, right? The link is attached in the description. And also, if you could extract anything out of the video, if you found the video helpful, just go in, like the video and subscribe to the channel. Bye bye. Thank you.